introducing our federal leadership on issues of sustainability. So let's go down the road here. This is Kevin Kempshire, the Deputy Senior Sustainability Official with the U.S. General Services Administration. Federal Director, Office of the Federal High Performance Green Buildings. So he will tell you what all of that means when it's his turn. Next we have Joanne Hill, the Chief of the Office of Business Development for the United States Department of Commerce, Minority Business Development Agency. We know it as the MBDA. She has served there for more than a decade. She also serves as the lead federal program officer for the nationwide network of more than 40 business centers that generated, it used to say $4 billion, but this year there's a spike, to $7 billion in performance goals annually. I can't balance my checkbook, so I can't imagine $7 billion. Congratulations. And next we have Landon Van Dyke, a U.S. State Department Senior MA Executive Coordinator of Sustainability. He currently serves as the Executive Coordinator of Sustainability at the U.S. Department of State. Big job. And we have Christine Klinger, the Director of the Army Sustainability Policy, Office of the Assistant Secretary of the Army for Installations, Energy, and Environment, with overall responsibility for Army-wide sustainability initiatives. So each of our panelists is going to speak for a few minutes, and then at the end you have your opportunity for questions and answers. So we're going to start today with Kevin Kempshire. And Kevin, come right on up here, and I'll put this back together for you.
Thank you.
There you go. Kevin Kempshire, give him a hand.
Thanks, and good morning. One of the problems is nobody ever told me how long I was supposed to talk, but they did say bring some case studies. So that's really what I'm going to concentrate on. And you can read faster than I can talk, so I'm not going to read the slides. You can just glance at them if you're bored. I just want to remind people that one of the reasons that all of us on the panel care about buildings is that they consume 40% of the energy in the United States, 70% of the electricity, and produce nearly a third of the greenhouse gases in the entire economy. I have a particular interest on the effects of buildings on human health and behavior. I've been researching that for more than 20 years. And it's important because we as an American society spend 90% of our time inside our schools, inside our homes, inside our office buildings, and 30% of those buildings have poor or potentially toxic indoor environmental quality. So that's where a lot of my focus is here. And I think it's also a focus of the administration because it's in this administration for the first time that the federal government did a comprehensive greenhouse gas inventory. And I give you one example of why that's important. We've been measuring the energy intensity of buildings for a long time. In the federal government, I can go back into my own system and look at the energy intensity of every building in our inventory since 1985, all online, all available to you to look at energy.data.gov. But at the same time, the smartest thing a building manager can do if he's only measured against one metric like energy intensity is to make sure nobody comes to work and nobody comes in the building, because then the energy goes down. It's the same thing happens in data centers and so on. If you have a very inefficient data center, it doesn't work well at all. It works great for energy efficiency, but of course it doesn't produce much. Greenhouse gases capture the totality of your operation. So if you've got a bunch of empty buildings in there, they're all producing greenhouse gases. If you can reduce from 3 data centers to 1 data center and make it highly efficient, your energy intensity may actually go up a little bit, but your overall greenhouse gases go down. So it's an extremely powerful management tool as well. We've also done some studies. This is the last published one. We're doing an update of it right now, of the difference between sustainably designed and operated buildings and ones that are not. The bottom line on the blinking screen, I'm not sure, I hope it's not bothering you too much. I don't know exactly what's going on, but you have better energy efficiency, you have lower operating costs, and you have higher tenant satisfaction. I'm not exactly sure what's wrong with that equation, but I don't understand with these kind of data why people aren't doing it. The other piece of data that you need to know is that in GSA's experience, we can build a sustainable building for about 1% more than a non-sustainable building. This is a trivial amount of money when you consider that the uncertainty in building cost estimating is plus or minus 10% if you're really, really good. And this is only a 1% difference. In other words, it's an unmeasurable difference in that way. So a couple of case studies. One of them is here in Washington, D.C. Anybody who wants a tour of the building can get my contact information, and I'll be happy to do it sort of late in the evening anytime that you here in town. It's a pretty cool project. It's a 1917 building here in Washington, D.C. It's only half renovated, so you can see the good after and the bad before all in one tour. It had air conditioning added to it in the 1930s, the late 1930s. The air conditioning didn't keep up with the changing desires of the population after World War II, so we installed 1,900 window air conditioning units in this building. And it qualifies as a genuine energy hog. It was running at about 120,000 BTUs per gross square foot per year, and a pretty extraordinary amount considering that's almost double the average in the GSA inventory. It's a great old building, 3 wings with narrow sections, 100% daylightable in the operating space. In fact, it was designed for daylighting because one of the first tenants, this was actually the first building in Washington, D.C. built for a specific federal tenant. All the rest were sort of general office buildings like State, War, and Navy, now known as the Eisenhower Executive Office Building. So multiple agencies, no particular name. This was built for the Department of Interior. And all of the cartographers for the Geological Survey worked in there, and they drew maps by hand back in those days. They needed great light. So there are very big, tall windows, emphasis on the northern light. The northern facade of the building is 70% glass. The southern facade of the building, only 40% glass. So there's a really good understanding of the heat load in a warm climate here. What we did, though, was we took a look at one of the great statistics, and that is office buildings in North America are empty 50% of the time during the working day. And we've done this on 230 different studies measuring workstation by workstation, by conference room by conference room. And if you look at all of those spaces, 50% of them are empty during the course of every single day. So we said we can do better with the density of the building. And in doing that, we increased the density from 2,500 people to 4,000. And remember, we're only half finished. When we finish the other half, we'll increase the density of the building to 6,000 people. Right now, today, we are saving $24 million a year in avoided lease costs for leases that we actually moved out of and canceled, so that's real bottom line changes there. We have eliminated almost all of the offices, except for the lawyers, and only 20% of the people in the building have a fixed address. So it's a rotating use of space. You sign up, you can sign up for a week at a time. Every organization has neighborhoods, so people know where they're going to find their colleagues. And groups can book groups together in there. We did a 250% increase in meeting rooms. It's not enough. The lesson we keep learning is that once people get used to this new way of working in the space, is that you need more meeting rooms, but people will actually use them there. We also did a tremendous amount of work on the energy of the building. It's the projected is 2/3 of the baseline, so a 66% reduction. We're using LED lighting in the hallways and all the places except the general office lighting there where it's still not cost effective. We've maximized the solar on the roof. We get 100% from solar thermal, 100% of the domestic hot water, as well as we have installed a whole series of cisterns that capture 95% of the water that hits the site on a major storm, and reuse it for both chiller makeup water and for flushing. So every drop of rain that hits the site is used at least once more before it actually hits the storm system there in the building. The operations inside the building are getting more and more sophisticated. You can see the changes that we have lots of different configurations of the workspace, but we're getting more sophisticated now to even to the point of if you're in a meeting room, you've got it booked for an hour, the lights will start blinking 5 minutes before the end of the meeting so that you can get out and the next people can get in. We have sort of on-demand electricity, and so if you're not booked in on Mondays and Fridays when fewer people come to the office, we don't even send electricity to the workbench, so if there's not there. And then we're experimenting with ideas on maybe even closing certain wings on the days where we still don't have a tremendous amount of occupancy. We have a perfect bell curve of occupancy. Try to get a meeting room on a Wednesday, good luck. Monday and Friday, plenty of room. Tuesdays and Thursdays is just about right. So Wednesdays are the tough days. Book early. We've also, one of the key things on meeting rooms there too, is to make sure that some of them are unreservable, because you've got to have a little flex in the system for those spontaneous meetings that you didn't have time to book in advance. And then you can see the hallways the way they used to look in the building and the way they do look now. It's a radically different approach. We've opened up the hallway so you can actually see where people were. Everybody thought the building was full beforehand until we opened up the walls, and all of a sudden you discovered that there was no there. And we found that out by experimentation, because we moved 1,400 people out of the building into completely open space where you could walk onto every floor and see, and you would just see nobody there. In the first 6 months of the swing space, only on 2 days did we exceed 50% occupancy, and that was only by 720 people out of 1,400 designs. Only 2 days in 6 months. People are already mobile. They are already working all over the place. They're already here, for example, and doing other things. And then you can see we've also added a conference center, which is pretty well booked. The other case I wanted to bring along is, it really gets at this idea of integrated design. The Edith Green Wendell Wyatt building was a Recovery Act project, and one of the things we did in the Recovery Act was to go back to all of these completed designs. If you recall, Recovery Act was all about shovel-ready projects. So we had designs completed but no construction money, and challenge every design team, and in many cases like this one, we had the builder on board as well, to go back, revisit the design, and make it better. Interestingly enough, we did this 43 times, and in all 43 cases, everybody said, well, of course we can do better. So the question then is, all right, if you can do better, why didn't you do better the first time? And the answer comes back to the way the federal government contracts for buildings, which is usually with a whole lot of specifications. They're very specific. They're minimum requirements, and everybody knows the federal government is cheap. Therefore, if you want to get the bid, you're going to cut it as close to the bone as you can, which means you're going to deliver the minimum, not the maximum. We were asking for the maximum. The interesting thing was, we got anywhere from 50% to 200% improved performance measured on energy alone with no extra money. Now, part of that was due to the economy being totally in the tank, and we got some pretty good bids. But the fact is, we actually did more work rather than put more money into this in individual projects. So the integrated design process here is how people did it. This was originally designed as a facade replacement. It had concrete. You can see in the sort of little picture in the lower left. Concrete, cast concrete facade framing, single pane, air leaking, water leaking windows. And what we didn't know until we started taking them off and they crumbled on the way down in the crane is that the concrete itself was actually becoming structurally unstable. You start out saying this is a facade replacement project. It's a two-phase, we'll keep half the people in the building. You challenge the team and say, give us the best you got. And all of a sudden they came back with some extraordinary differences. First, change it to a move everybody out project, one phase, not two phase. And then we can address the mechanical system. What happened with that? Why didn't that cost any more money? It doubled our swing space costs, it doubled our move costs, but it cut 1 year and 3 months out of the construction schedule. So that actually made up for all the swing space costs, because now we're not in swing space nearly as long. Second of all, by addressing the mechanical system, they went from a totally air-based system to a water-based system with radiant heating and cooling, and therefore a WGES 100% fresh air system for that with much smaller ductwork. That change, and the fact that moving heat in water is, or in a liquid, is about 3,500 times more efficient than moving it in air, meant that we recaptured the equivalent of one entire floor of space just by not having the vertical air ducts in the building. We also went to programmable elevators, again, regenerative elevators. We're able to eliminate 2 elevator banks, more space, more rental income from the building, plus eliminating the facade on the outside and putting a modern facade gave us a foot around the entire perimeter of every floor. So we now have a building with 2 extra floors of space without adding any extra floors. Plus, the top floor mechanical room, which was